Potential energy of an electric dipole in an external field is U equals to minus P dot E. Now let us find out the equilibrium positions of a dipole in an external field. Now the conditions for equilibrium is that the net force on a dipole has to be 0, as well as the net torque also on the dipole has to be 0. Now if the electric field is uniform, no matter how you place it, the net force will always be 0, so that's not an issue. The issue is when the torque is 0. So if you see the formula of torque, if you just take the magnitude, this is Pe sin theta. So if theta is 0 degree or 180 degree, in both the cases torque is 0. So theta equals to 0 is an equilibrium position of the dipole, as well as 180 degree is also an equilibrium position, but one of them is stable one and the other one is unstable one. Now which one is stable or which one is unstable? For that we need to see the potential energy of the dipole, right? Now always remember, at stable equilibrium the dipole will have the minimum potential energy. Okay, now if you see for theta equals to 0, the total energy is, if you take the value minus Pe cos theta, so cos 0 is 1, so energy is minus Pe, so negative. For theta equals to 180 degree, U is plus P. So both of them are equilibrium position, but this one is stable, so stable equilibrium, and this is unstable. Now what does it mean by stable? If you draw it, now if you draw the dipoles in the electric field, this will be the stable equilibrium, this will be the unstable equilibrium. In both the cases the net force as well as net torque is 0, but if we rotate this case, in this case in stable equilibrium, if we rotate it slightly, this will come back to this position, that is minus q at this point plus q at this point. But here if we rotate them slightly, it will take its position, that is plus q will come here and minus q will come here. So these are two equilibrium positions of a dipole.